What is this? Oh, that's my speaker. Not that one. This one. I have a new circuit here. Let's see. Oh, we have lots of LED. One is lighted, the green LED resistors, and this one, blue LED, and IC. Let's see the circuit. Push the button. See? This is known as the famous Johnson counter. So we have some LED here, and this one is the power section of this one, 9 volts from my 12 volt supply. I don't have 9 volt supply, so I have a power section here. So this is a famous counter, Johnson counter. Every push, the light is shifting into the left, to the left. See, with the help of CD4017. And let us check the circuit of this jungle mesh porous. So we have this 4017 Johnson counter, CD4017BE. That is the IC, known as the decade counter or frequency divider, or in this case, this is a Johnson counter. So we have in the pin 1 is connected to 6 diode 6 D6. Pin 2 connected to D2, pin 3 connected to diode 1, and then pin 8 is grounded, pin 16 BDD, pin 15 reset, pin 14 clock. That is pin connection connected to the switch, because this counter is used also using a security lock or code. And we have here a 9 volt supply, so the push button is here connected to the clock. That is our clock using the button. And we have the pull down resistor here, and this one is the green LED, this one. When you push the button, and pin 13, that is enable. It is used to freeze the circuit or freeze the LED. Since we don't have clock, we don't need to freeze the light or LED, because we're using it as a Johnson counter, a sort of manual counter. Or some said, according to my idols on YouTube, it is a ship register, some sort of that. This one carry out, no connection, 11, 10, 9 connected to the LED. So we have a series resistor of 220 ohms. Computing the value of the resistor here. So directed to the ground, connected, and this one is my converter, 9 volts regulator. This is from manufacturer's data sheet. So BI is 12 volts converted to 9 volts. the gate here. In the input side, we have one opal capacitor, and the source is grounded. And then we have output capacitor of 10 microfarad and 16 volts. The use of this input capacitor is when your wiring is long, and this capacitor is used, the electrolytic capacitor 10 microfarad 16 volts, in order to improve the transient voltage response. Upon turning up the power, there is some sort of voltage coming back to the IC, damaging this IC. So this one protects transitional voltage response from the voltage load. And this was my LED blue. This one, power indicator. The output is 9 volts. We have a diode here. See? That is in order to counter any current from the voltage load or load of the circuit. It flows back to the input, and then protects the IC from damaging. When you switch off the circuit of the load, there's a tendency that the capacitor is discharging from the circuit of the load, entering into the IC or AN7809, our regulator. So we need this diode to bypass that voltage, reversing voltage. Diode is IN4001 from datasheet. It has a reverse working peak reverse voltage of 50 volts. So that's a protective diode we're using, up to 50 volts protective for the peak reverse voltage or any short circuiting of the load. So we now know we have a switch here. When you push the switch, the LED lights, and the application of this counter is we're just shifting the light from left to right. This counter is very good, huh? Okay, we can apply this using, or we can apply this for security code lock, since the sequence of the light is in pin 3, 2, 4, 7, 10, 1, 5, 6, 9, 11. So the first light is from pin 3. First lighting, pin 3, diode 1. Second lighting, pin number 2 to the diode 2. So that is the sequence of the light when you push the button. There's a sequence, sort of frequency divider in one frequency. It divides some sort of that. Okay, let us see the circuit again. Push the button. See, it's shifting the light from right to left with the use of CD4017, a famous Johnson counter. Let us see if we can build this in PCB with our voltage regulator blue. Let's build the circuit. Okay, thank you.